Tonight's presentation, Sonex Highwing Update. And our presenter is Mark Schabel. Mark is owner and president of Sonex LLC. He's been with the company since 2003. He's owned it since 2022. He serves on the EAA's safety committee, volunteers coming together to talk about very important safety aspects for the home-built community. A really vital role. We sure do appreciate Mark's volunteering in that very important safety committee work. Mark led the 1 Week Wonder project where we built a Sonex YX here at EAA in 2022 over the course of 7 days. Pretty awesome. And of course, a member of EAA for many years. Mark, thanks a lot for being with us tonight and sharing all this cool information about a new design aircraft. I'm going to turn control of the presentation over to you.
All right, thank you, Tim. And looks like you can see my screen.
Looks good on my end.
Great, thanks. Well, welcome everyone, and thanks for tuning in. I see we have a good number of folks here. Hopefully that number continues to go up as more folks are able to show up. And really excited to present this information to you tonight. There'll be some old news, there'll be some new news, and you'll have your chance to answer your questions. So of course we're here to talk about the Sonex Highwing, which is our newest design. And if you want more information about the Highwing and to look at past webinars, we now have a few webinars on the Highwing archived. Our last one being on January 30th. You can see the screenshot there. You can go to eaa.org/webinars, or you can go to our website, sonexaircraft.com/webinars. And there's, in addition to just webinars, there's a ton of previous project update posts that are, text and pictures. So you definitely want to be sure to check those out. You'll also see all the webinars in the same place offered at sonexaircraft.com/highwing. And I encourage everyone who is seriously interested in the airplane to join the Sonex Highwing updates mailing list. And you can see a little screenshot there on the right of the subscribe form, and you'll find that on every post that we put on our website about the Highwing, including the one that was advertised in this webinar. So please join the mailing list if you haven't already. Can't do a presentation about anything Sonex without thanking our incredible staff and family. This is a picture from the last year's AirVenture open house that we had at our factory. This is not our entire staff. We are 10 people strong, including myself and my wife. So this is all of us plus a number of builders and soon-to-be builders who came to the open house the day before AirVenture and checked out our facility and our aircraft. But thank you to everyone on the Sonex team for making everything we do possible, and they're just fantastic. This year, 2025, is the 27th year of Sonex being in operation, and you can see the original Sport Aviation magazine cover up in the upper left there of the Sonex. Of course, Sonex was founded by John Monette, and he got his start in home builds much earlier than 1998. You can see his first Sport Aviation cover photo on the lower left from 1972 with the Sonnery 1. You can see his biography in the upper right there, John Monette from Sonnery to Sonex. So you can learn a lot more about him through his biography, which you can find on our website as well. Now, of course, as Tim mentioned, I've taken ownership of the company since 2022, and I've been running the show since then. So Sonex has three major product lines. The aircraft, of course, starting with the Sonex and then going through the other models, the YX, the Xenos, the 1X, the Subsonics, and of course now the Sonex Highwing. Aero Conversions is our brand for things like the AeroV engine, the aero injector, our unique hydraulic brake system, and some of our other accessories that you can use on any experimental aircraft. And Sonex Aerospace is our brand, I'll call it, our division for doing unmanned aircraft work. And you can find out more about that on our websites as well. So getting back to the subject at hand, the Highwing, I'm going to not spend a lot of time rehashing material that I've posted in the past on webinars or that's already on our website. So you can definitely, again, I encourage you to go to sonexaircraft.com/highwing to bring yourself up to speed. If maybe I'm getting beyond your basic knowledge level for the airplane here, but the Sonex Highwing is intended just basically to be a Sonex with the wing on top. So why build a high wing? So, you know, we first talked about the concept to build a Sonex high wing way back in 2010. As I've said on many, pretty much every webinar so far, my initial reaction to the idea was, yuck, that's not what we do. You know, the more I thought about it though, the more it made a lot of sense actually. So, you know, why are we doing a high wing? Well, you know, we've never served high wing people. You always hear people talk about either being high wing people or low wing people. So, you know, let's say they're split roughly 50-50. That's, you know, easily 50% of the marketplace that we've never appealed to before. So we're hoping to crack into some of the extra bodies out there in aviation that want to build an airplane. A lot of advantages for ingress and egress and the aging pilot population that we always hear about. And of course, you know, folks with limitations with their mobility, disabled pilots, folks, you know, that have the scholarships, like our disabled veterans who get their scholarships to get their private pilot license. Lots of other folks out there too that want to fly a fast, sporty, and aerobatic airplane and need to be able to easily get in and out of it. It's also a great opportunity to serve taller pilots. The Sonex, you know, is a relatively small airplane. Depending on body geometry, how you're proportioned, legs versus torso, we can fit a number of pretty tall pilots, you know, 6 feet and over, again, depending on how they're proportioned in a Sonex. But with the high wing, just the nature of sort of squaring out that overhead with the wing above you gives you a lot of opportunity for even taller people. It's easier, you know, to provide more baggage space, again, for that same reason, in terms of just sort of squaring out the fuselage and the area behind the seats. Most high wings out there nowadays cater to the STOL crowd, and we didn't want to do that. So, you know, there aren't a lot of aerobatic capable high wings, certainly in the home built space, and that's what we wanted to do. You know, it's kind of a connection to our design heritage. One of the things that I've heard a lot since we started showing the finished airplane was, you know, that's a Whitman tailwind. Looks just like a Whitman tailwind. Well, yeah, of course it does. Sonex has already had a lot of Whitman influences in the design of the airplane. The flat bottom of the fuselage, the airfoil shaped top of the fuselage, some of the other basic design features. And of course, John Monette and Steve Whitman were great friends back when Steve was still with us here in Oshkosh. So yeah, definitely, it's a great way to connect with that heritage and in a sense with the legacy of Whitman. And of course, an opportunity to do a new type of airplane our way in terms of offering the best performance per dollar with simple construction and all of the other attributes that we're known for. So the high wing, you know, really became my baby a few years ago. I want to say it's been maybe 6 years since I started really working on it in earnest. And I knew that, you know, I had some of my own criteria, and I didn't feel the airplane was worth doing if we didn't have these things. More useful load, we wanted to offer more utility. I wanted to offer more utility in this airplane for people to really load it up with 2 full-size people, full fuel, and a good amount of baggage. and be able to have an airplane that they can fly with Sonex-like performance and handling in a high wing. I wanted it to be a cantilevered wing. Was not interested at all in building an airplane with struts as a Sonex Highwing. You know, it helps egress and egress to not have it, and also greatly aids in the aerobatic capability, just having a cantilevered monowing structure. We wanted it to retain Sonex performance and handling standards, and I'll talk about that as we go on here. As I mentioned before, easy ingress and egress, so not just being a high wing, but making sure that it had a large door that exposed the footwell, and having the options of center and dual stick options. That's something we've offered both options through the years, and you know, it's people want the exact opposite of what you're offering when it comes to that, it seems. We only offered center stick in the very beginning, and then of course everybody wanted dual sticks as being more conventional. In other words, a stick for each occupant versus one in the center of the fuselage. And then you know, people started asking for or wanting to go back to finding the merits of the center stick installation as far as just sort of a little bit more comfort in the cockpit and things of that nature. And of course, with a high wing, we wanted to offer both because a center stick was really important to me, again, for ingress and egress. Without having the stick in the way to throw your leg over the airplane, it's like getting in and out of a car. So that was really important to have both of those options. And I won't, this is really the only time to talk about it. I don't have a slide about it tonight, but if you go to my past presentations, you'll see that we offer a modular stick system. So you can actually, between flights, remove the stick and reposition it, or even get into the airplane and then put the stick in between your legs if you want that conventional you know, dual stick setup, or you can, you know, not have a stick on the passenger side or whatever. So it's a really nice modular system. And then reasonable step in height. So again, like I said, getting in and out of a car is kind of the experience of getting in and out of the high wing. You know, the Sonex generally, because of the engines that we use mostly, allow us to not have extremely tall landing gear, and so that makes the entry height of the airplane, excuse me, the entry height of the airplane very reasonable. It's not an airplane you have to climb up into. So that again makes it easier for people with maybe a little bit of challenge for mobility. I wanted to offer more cockpit space than we previously had in any of our existing designs. More baggage space, again, you know, offering more utility, more useful load. I wanted to offer aux fuel options. In other words, more than our standard 20 gallons. Even though we're using engines in the same sort of range, I knew that being a bigger and you know, a heavier airplane at the end of the day, that folks are going to want to use some of the larger versions of the types of engines that we typically use that will burn a little bit more gas. And people would really want to use this as a cross-country machine and be able to travel further with it. BRS options is also a design criteria, also a design criteria for me. And again, just keeping it optional. It's not something I want to force on anyone because it does use up a lot of useful load. But there is that portion of builders and pilots out there that just have to have it personally for their mission criteria. A high wing aircraft is much easier to configure for a BRS than a low wing aircraft. So it was kind of a no-brainer. And that's because of the wing being on top. All the attach points for the parachute is much closer to where the chute exits, and doesn't get anywhere near the pilots in terms of worrying about harnesses cutting through the cockpit and an unusual attitude or anything like that. So we are working with BRS. We had a good meeting with them during AirVenture again this year, and we're working on getting things together with them to do the installation on our second prototype, which will be the Tricycle gear version. I wanted to offer EAB and ELSA options, and maybe SLSA. Of course, along through this process of designing the airplane, Mosaic came along, which offered some opportunities to do more with the airplane. And we are designing the airplane in accordance with the ASTM standards. Of course, there'll be a slightly changed set of standards coming, probably not for another year or so for Mosaic, even though Mosaic is now a rule. So yeah, we're looking to take advantage of that. And that may even include, not a guarantee, but it may even someday include factory built finished airplanes. It was important to me that the airplane fit as a finished aircraft in a shipping container. And, we have removable wing options for all of our airplanes. I shouldn't say options, I should say features. All of our airplanes have removable wings, and wanted this to be no different. We have to be able to sell the quick build kit, where we build most of it for you, or a finished, let's say SLSA. I have to be able to ship it. Certainly isn't efficient to try to do ferry flights across oceans to get a light sport aircraft off to people in other countries. And finally, it needed to look good. It needed to have a certain sex appeal to the airplane. And I think we accomplished that. Opinions abound, whether you like it or not. And I've heard from both sides of the fence, but I think we succeeded. I think it turned out to be a really nice looking airplane. So we had our first flight of the first Highwing prototype, which of course is the tail dragger, on June 30th of this year. You can see the airplane there. Actually, didn't have wheel pants or gear leg fairings fitted to it yet for that flight, but it was flown by Joe Norris, who's on our advisory board. You can see him there giving the test pilot thumbs up. And it was a successful flight. We had a little bit of a challenge in having the passenger side door pop open, so we had to fix that before the next flight. So we kept it brief, but it was a good, successful flight. Through the month of July leading up to AirVenture, we did a bunch more flying and collected a bunch of data. And I would say that data still holds as valid data today, and we'll go through that. So we got to AirVenture with the airplane this year as a finished aircraft for the first time. You may recall in 2024, we had the fuselage and the center section of the wing displayed on its gear, and people could try the airplane on then. But this year we had the finished aircraft with a couple of hours on it for display. And the picture here, the biggest picture here is basically what you saw around the Highwing all week. And this is actually one of the more, I would say this is a little bit of a lull in the traffic, which allowed us to get a picture where you could actually still see the airplane. But people were around it, inside of it, looking into it all week long. I did a ton of interviews with aviation media and YouTubers, and you can find those posted on our Facebook page and all the individual YouTubers' websites. In our next published website update, where I'll post the archive of this webinar, I'll try to post some links to some of those interviews if you want to check those out as well. There again at AirVenture, you see Paul Dye and Tom Wilson, formerly of Kit Planes. We're still with Kit Planes as of AirVenture. If you haven't followed the shakeup at Kit Planes, I invite you to. I'll stay out of that fight, but I'll say that you want to follow Paul Dye and other compatriots over at AvBrief. They are doing it right over there, and also the folks from AvWeb and elsewhere that have gone over to AvBrief. But anyway, Paul Dye will be doing a flight review of the airplane later this fall, weather permitting. Of course, it is Oshkosh after all, but tentatively at this point we're talking November. And Paul will be writing about flying the airplane. We'll have some other journalists, flying the airplane as well, as weather allows and their schedules allow. So you'll start to see some independent flight reviews of the airplane. On the lower left there, In case you were curious, yes, you can get a cover for the airplane. Bruce's Custom Covers very generously furnished us a prototype cover for the new airplane, and it worked out great. It fits beautifully, and so if you're building a high wing, I highly encourage you to check them out. Bruce's Custom Covers, if you want a cover for the airplane when it's tied down somewhere outside. So performance, we'll start getting into the meat and potatoes here. These are pictures that I posted right before AirVenture, and like I said, these numbers are still valid. I mean, this is what the airplane does. So you can see some screenshots here from the Dynon display that we have in the airplane, the dual screen displays, the 10-inch Dynon units that, again, generously furnished by Dynon. So thank you, Dynon. Of course, in this airplane, we have the UL 350 IS. So that's the 130 horsepower, high compression version of their 4-cylinder engine. And I'll talk more about that. It's a very impressive engine. We're really, really pleased with it. You can see here on the left, we're at 2,500 feet or so, maybe a little bit more than 2,500 feet. We're at, your typical cruise RPM, about 2,800 RPM, indicating 150 miles an hour and truing out at just shy of 160. So if there was any question in your mind about whether this airplane was capable of Sonex performance, the answer is yes. Now, of course, to get apples to apples speeds, you're going to need a little more horsepower because it is a bigger airplane. It has more frontal area and wetted area and all of that. But the airplane is very slippery, very fast, and we're really, really pleased to be able to show these numbers. On the right, you can see we're throttled all the way back to 2,550. We're actually climbing a little bit at 250 feet a minute in this particular screenshot, indicating 135, again at 2,500 feet, true airspeed of 143. So really good stuff. Here's another slide that we posted in that post we made before AirVenture, and this is kind of an average true airspeed with fuel burn. Again, this is 2,500 feet. And you can see with the UL Power 130 horsepower engine, we're truing out at about 160 miles an hour, burning about 7 gallons an hour. Now, you don't have to throttle, as you can see, you don't have to throttle back very far to get to just above 6 gallons an hour. So, you got a lot of flexibility here in terms of how you want to flight plan and how you want to fly your cross country to get the most legs on the airplane. I want to give a shout out here to actually a Sonex builder, Michael Jackson. Is both a Xenos and a 1X builder, and he developed and sells this software that we have here, and I have the link on the upper left of your screen. The software is called Flight Data Viewer, and it's a really great software to use for your flight test program to go ahead and reduce your data. Because if you've worked with an EFIS before, you pull out the data card, and what do you get? You get a giant spreadsheet, a big CSV file, and you have to sift through the sampling rate, which is about a data sample about every second. And it's really hard to get, distilled data and analyze data. You can see here, this is one of his analysis pages, the RPM, true airspeed / fuel flow analysis. So he's got some really powerful tools in the software. I highly recommend you check them out. Here's a comparison at 8,000 feet. This was actually done earlier this week. Now we've got a different prop on it than we originally had, and we had a Sonex fixed pitch wood core composite coated prop, which is really what we like the best on our airplanes. But we didn't feel that we had quite the right pitch on the first prop that we got for this airplane. So we talked to Sonex as we were flying it just before AirVenture. Talked to them again at the show, and they wanted to send us one of their ground adjustable props. So they did, and unfortunately, it took some time. They didn't have anything in stock. They had to make it, and so we only just got it installed and flying at the end of last week. So we haven't quite dialed in exactly what pitch we like for it yet. And it is a more rigid composite blade, so nothing that Sensenik did wrong, but I'll tell you, I just really like wood props better. For a lot of reasons, and I can explain that if you're interested. I won't take up too much time talking about it now. But anyway, we got the prop. We've tried a few different pitches. It's not quite as fast, so we obviously don't have it pitched quite right. So we'll be playing with that. But you can see here at 8,000 feet, similar RPMs, let's say 2,800 RPM. Now we're burning 6 gallons an hour versus 7. So the altitude obviously saves you fuel. It should yield more speed, but it didn't in this test. Again, I think having to do with where we had the prop pitched. Also, I think we changed the size of the tires, just some testing with 505 tires, and we put wheel pants on them before this flight, and I don't think we had them rigged quite right, and they were maybe creating some drag versus reducing drag. So, one of those things in flight test, we'll be working that over the next few weeks and refining that. Stall testing we did before AirVenture. You can see the screenshot here of Joe Norris doing some stalls. We have a couple of different videos on our website of him stall testing. One of them is this view showing the entire flight. Another one is a 360 view of just the stall series, which is pretty cool because you can, with your mouse, just pan around the cockpit. And it was great for our looking at the flight afterwards from an engineering perspective, because through the stall buffet and everything, we could actually pan into the tail cone and down to the floor and look for any weird vibrations, anything like that. And of course, we didn't see any. Everything was rock solid, but it was great to be able to just pan around with the 360-degree camera and analyze all that. And it's pretty cool for folks like you to watch, because again, you can just watch from any vantage point you want and just get a good feel for the inside of the high wing cockpit. So the stall speeds Joe collected that day, clean, with no flaps. He was about 54 miles an hour. Half flaps about 51, let's say, and full flaps about 46 and a quarter. And of course, that's solo, pretty light configuration. I'll go over some weight and balance stuff here later, a little bit, a few slides down the road. We know, of course, those speeds will go up at full gross weight. Of course, this is the shorter wingspan installation. I'll talk about that a little bit more. So the full span wingtips will help alleviate increases in stalls with the heavier weight, but obviously we can load this airplane up with a lot more weight than what was in it at this flight. What does that mean for you? Well, it means that you still have a sport pilot legal airplane. So with the new Mosaic rule, you can see there for sport pilots, one of the things that confused a lot of people in the new rule is that they published 2 different stall speeds. Basically, the reason for that is that one of the specifications was the sport pilot limitation. The other specification is the limitation on the aircraft itself to be a certified light sport aircraft. In other words, to be a private pilot to fly a factory new LSA. The airplane, you don't have to stick to that 59 knots clean. Anyway, it confuses a lot of people, but basically those are the numbers. 68 miles an hour is your stall speed limit as a sport pilot, and we'll be well under that, even if max gross weight with the airplane. Climb, again, this is with the short wing tips, so it's going to be a little bit limited, but solo, so it might be a wash at the end of the day when you get 2 people aboard and the full span tips on it, which we'll be talking about later. Average about 1,200 feet a minute is about what we're seeing in ideal scenarios on your climb out from takeoff. And again, this is a great example of the flight data viewer software at a roughly 1 sample per second data sampling rate, you see a lot of noise. You see those yellow spikes in the graph there. And so when you're just looking at raw data on a spreadsheet, just like when you're flying the airplane, you're going to key into the highest number that you see and say, my airplane climbs at 1,400 feet a minute. Well, no, it doesn't. You have to look at the, get rid of the scatter, get rid of the noise, the high points, and actually average the data out. And the software is, again, great for that, and we really like having it. Temperatures. So again, the UL350IS, we are extremely happy with how it's performing. It's been rock solid and cool as a cucumber, frankly. And that really surprised us because it's very tightly cowled in our airplane. I'll show you a Firewall forward picture here in a minute. You know, you can see that, you know, geez, cylinder head temperatures, you know, hardly get above, you know, anywhere close to 300, which is amazing to me. EGTs, of course, are all behaving. Oil temps, they're doing great too. Sometimes maybe you'll see 220 or so. Maybe you'll be in the yellow arc on a climb out on a hot day, but you know, you throttle back, you level out, and that oil temp comes right back down. So these are really great numbers. We're really pleased with them. Now, the UL power engines are more oil cooler dependent, and that's why you see such low cylinder head temperatures in the engine. So you can see here the Firewall forward. We had the airplane with the cowling off for an afternoon during AirVenture with Herman from UL Power out there and myself talking to anybody that wanted to talk about the engine installation and had questions about the Firewall forward. You can see the cowling installation there. It's basically a Sonex B model cowling, but we did make a couple of modifications. We took, and you can see, let me grab my pen here. You can see sort of the ghosts from the original cowling where we cut out the cooling inlets in their original location and moved them outboard on either side. And then also, of course, because it is a more oil cooler dependent engine, we needed to put the oil cooler prominently in front of the cowling. So we did have to make and glass in a scoop for the oil cooler, which we kept, you know, worked hard to keep as not obtrusive and as attractive as possible. Here's a nice little side view of it down here. So we'll be offering, at the very least, we'll be having glass-in pieces for UL power installations. I think in the not too distant future, and we may just jump straight to this versus messing with glass-in parts that you have to work with, and we'll just have just a UL power version of our cowling. So to do that, we have to have a pattern made, basically have a plug made, and by a pattern maker, and have new tooling, have new molds made, and you know, we do plan to do that definitely eventually. In the meantime, we might just have, again, these glass-in pieces that you get with the standard cowling, and you basically just graft them on. You can see from the cooling exit perspective, we didn't do anything drastic here. We just have a lip at the joint between the Firewall and the bottom of the cowling, the aft bottom portion of the cowling. At the proper ratio, we have a lip on it. It's only about 1 inch tall, so very, you know, relatively low drag, and the engine, just as you saw with those temps, cool really great. You can see we got a nice tidy little exhaust installation there, as I circled as well. Looking at the Firewall forward picture, one of the things that I was really concerned about with the Sonex cowling is this area right here. Maybe I ought to use a different color. Try an orange. This area right here where the intake tube is in the forwardmost bank of cylinders. And so that's a real choke point, as you can see, where the baffle seal is. And I was really concerned about that number 3 cylinder hiding back there. And it is our hottest cylinder, but again, because the the UL power is kind of a little bit more oil cooler dependent. We haven't seen anything anywhere close to the limits for CHTs with the engine, even on the hottest days and the most severe conditions. So again, really great. Now we've had several people through the years install UL power engines in Sonex's, you know, we sell motor mounts for Sonex YX Xenos for UL power, and now 1X as well. And you know, you know, people made some cowling modifications, you know, thinking that they had to, or maybe trying to work around a problem that they were having, maybe because they didn't have enough exit area or whatever. And but we've proven here that it's a pretty stock installation of the cowling, and it works extremely well. One of the things that we will be doing as far as a quote unquote firewall forward kit, we already provide the motor mounts. These cooling baffles come with the engine. We'll be providing sort of the drawing for cutting them to this profile to fit our cowling, and we'll be providing the pieces where you'll actually be cutting their baffles and kind of bending this down ramp here. I hope my drawings are showing up okay for you. And we'll have these pieces in here to keep it all, you know, keep the fence there. And we'll be having more support, more parts for that now that we've actually done a factory install of the engine. Everything else was pretty straightforward. Even though it is an ECU controlled engine, it turned out to be a really nice and tidy install. Now, of course, this is not the only engine that we offer. We are, you're able to do the Highwing with all of our traditional engine options. I would say maybe with the exception of the 80 horsepower AeroV. You know, I think you're going to want 100 horse or above. We will be doing reduced power climb and cruise testing with this prototype with the UL power engine once we get all of this prop testing finished, and we're sure that we have sort of the best performing prop on there that we can. Then we'll be running the engine at reduced RPMs per UL Power's torque, power and torque curve to simulate the AeroV 80 horsepower and the 100 horse turbo, the lower powered options for the UL Power 4 cylinders, and the 120 horse Jabiru 3300, which I think also is going to perform really well in the airplane as well. Rotax 9 series, 912, for instance, we won't be able to simulate as well because it has a reduction drive. So the torque curve is completely different. Because of the torque curve with the reduction drive, I don't have any concerns running 100 horsepower as let's say a minimum, maybe 80 horsepower with the 80 horse Rotax as well, or bigger. I know the Rotax will work fine in the engine, in the airplane as well. Weight and balance. So the airplane, as all designs do, ended up a little bit heavier than, you know, we kind of wanted it to be, designed it to be, but within reason. And one of the reasons that we set out, especially with Mosaic, kind of getting rid of weight restrictions, one of the reasons we set out to design the airplane with a 1,500 pound gross was so that, you know, we knew it was going to weigh a little bit more than what we were calculating, and we wanted some margin in there. So you can see in the upper left, our actually the whole left side, our first flight, our flight test, CG condition, empty weight of the airplane is 816 pounds or thereabouts currently, and we did change the tires, but that's about what we weigh. You can see our first flight weight with roughly 210 pilot and about a half tank of fuel, and we were really light at 1,000, let's say 1,100 pounds. Now, as we get the full span wing tips on it, and also the auxiliary wing tanks in the airplane, which are not currently installed, we know the empty weight is going to go up a little bit. Basically estimating about 850 pounds, actually 844 according to my math. which is subject to incorrectness, I'll just say, but we'll have roughly an 850-pound airplane as a fully featured airplane when we get it outfitted. And you can see still, you know, our kind of our max aft CG condition dictates what we can do for getting the max gross weight in terms of you know, what we can put in the baggage compartment. We can see full fuel in terms of our 20 gallons in our main tank, our traditional 20-gallon Sonex header tank, and 10 gallons per side in the root wing section, the non-removable part of the wings, in our 5-gallon aux size, so 5 gallons each side, 10 gallons total of aux fuel, 76 pounds of baggage, and 2 200-pounders. Now, of course, when you're flying solo, you can get, you know, we have weight and balance scenarios showing you can stay within CG up to 90 pounds or a little bit more than 90 pounds of baggage as you burn off fuel. So lots of capability in this airplane. Now, you know, painted, the airplane will be a little heavier. Tricycle gear, it'll be about 10 pounds heavier, maybe a little less. You know, it's a home-built airplane, so weight's going to vary. In the amateur-built version, weight will vary based on equipment, as like engines and of course avionics. You know, we have kind of a heavy avionics package. You know, we really like this Dynon installation, but it is a little heavier than what we traditionally used to use with MGL or what we have in our other airplanes, which is very lightweight. So there's a lot of variables there in terms of your empty weight. As you all know, as home builders, there's all kinds of ways to make your airplane heavy. The challenge is to be disciplined to not make it too heavy. We'll get into the aerobatic scenario here as well. So going back to that 816 pounds with the short wing tips on it. You know, maybe it'll be you know, 20 pounds heavier, or it won't even be that. It'll be about 10 pounds heavier if you have those wing tanks installed. You won't use them, of course, for the aerobatic profile. Now, our airplane is designed to be able to fly aerobatic solo, but also be the first of our in our line of airplanes to be aerobatic capable with 2 people on board, and that requires the short wing tips for structure, having basically less moment arm on the wing spar, especially at the root. And so we have a couple different specifications here. We have sort of the full aerobatic category limitation of 1,230 pounds, which is basically your solo aerobatic configuration. And then we have what we are calling a limited aerobatic configuration, which limits you, instead of 6 Gs, you're limited to 5.5 Gs. Kind of like an American Champion, like a Citabria or whatever. You notice that you know, they have less than 6 G aerobatic weights for 2 people on board, and they can fly actually at their full max gross weight, I believe, aerobatic or not. So you can see here these weight and balance sheets, whether you have 1 pilot on board or 2, are more than enough. So even if your airplane is a little bit heavy, you know, especially with 2 people, well, you know, you can fly with half a tank of gas to do an aerobatic flight. You still got plenty of endurance to go up with your buddy and do some aerobatics. Now, when we get to SLSA, I don't think the standards are going to allow for that reduced G loading for the aerobatic mission. So that's something we have to TBD. The Citabria, for example, was certified under the CAR standard. I forget the number, but CAR part whatever versus FAA part 23 that we have now. So that's kind of a grandfathered standard. But for amateur built, it doesn't matter. You can do it this way if you want. Handling and comfort. So the airplane flies like a dream. If you've watched our Facebook, and you'll see we have a couple of videos out there of flying the airplane hands off. It is smooth. It is stable in a stable flight configuration. It is still neutrally stable. In other words, it'll stay pointed where you leave it, like a Sonex, which is, part of the sporty aerobatic handling qualities that we want. But the rigging is fantastic. It's, just straight and true and just an absolute joy to fly. We do some flights with 2 pilots on board, as long as the second pilot is mission critical, and we have done a fair bit of that for handling, evaluation, and some other things. It's also an easier and I think safer way to versus loading up 200 pounds of ballast in the seat next to you and securing it properly. That's a little bit scary, really, when you think about it, if it comes loose. So you can see we got AJ from our staff and Tom in the airplane here, and the pictures on the left, and you can see, I mean, it's just such a comfortable airplane. The Highwing, of course, is bigger than the Sonex on the inside. It is wider. You don't feel at all that you're in each other's personal space. It's just really, really nice. And you can see the views there, especially on the left with the skylights. And yeah, even though we have that, some people call it unibrow windshield installation, the visibility is still really good. You have plenty of forward and upwards visibility through the skylights, or if you just lean forward a little bit. So scanning for traffic is absolutely not an issue. And it's a nice, light, airy cockpit with great visibility. Wingtips, so I talked about that a little bit. As I said, we're flying with the short wingtips, just those end plates like you saw in the AirVenture photos, and elsewhere on our website. And that's, like I said, the aerobatic configuration. We have, as you can see in pictures here on the right, this was actually taken today. We hot wired some foam, and what you see here is the plug that was glassed out of that foam, the male plug that'll make the female fiberglass molds for the tooling. And that's, so they'll eventually be composite wingtips. The wingtips attach with piano hinge, just like the Xenos motor glider, which also has interchangeable tips for different missions. And that's pretty easy because you just take a pair of needle nose pliers and you pull the hinge pin out from the rear spar between the aileron and the wingtip, and just zip the tip right off. So it's really quick and easy to interchange the tips. And of course, if you have lights like we're going to do, have landing lights and our nav position strobes in the full span tips, you just have disconnect for the wiring, really easy to do. On the left there, you can see a metal wingtip going together, and that's just because we really need to get some full span flight testing in, just like the prop being a little bit later than we wanted, the new prop. Getting these composite, getting these molds done for these wingtips has taken more time than we wanted as well. It's just the way it goes. But we really need to fly the full span as soon as we can. So we're building a temporary set of metal wingtips. We are not looking to do the metal wingtips as sort of the what's in your kit. They are, even though it's all matched holes and everything, just like a wing, you have to make sure it's really squared up. And so they're actually a little bit of a hassle to build on a metal, although it can be done. So the fiberglass will be much easier. That's what you have, or maybe even carbon fiber if you really want to save some weight. Maybe if we have enough demand, we'll offer an upgrade in carbon fiber for the wingtips. So one of the reasons why we really need to move on to the full span tips in the flight test program is still part of the evaluation of handling of the airplane. In the short span configuration, the rudder on this airplane is really sensitive, and it's fine for the aerobatic mission. It's actually not a big deal even when you're not doing, when you're just flying around. But it's sized for the full span configuration. The other thing too, so basically with the full span tips, we just need to make sure that the rudder is what we want it to be sensitivity wise for your everyday flying. Just toned down a little bit from what it is now. Essentially, the rudder is super effective. Part of that is, you know, just being a high wing airplane, the wash of the wing, it flows into the tail and kind of energizes the flow, kind of like vortex generators would in, you know, in a race car or on the wings of an airplane. And so it does make the rudder more powerful. So with the longer span, that will bring the rudder back down. It should bring the rudder back down to where we want it. And just want to make sure that, you know, we don't have to do something like, you know, like the tailwind does and shorten the rudder a little bit and have, you know, full chord stabilizer above the rudder. In other words, that tip would come down further essentially, although it wouldn't all be fiberglass. What you can see here with this air-to-air photo and this picture on the right is some end plates on the ailerons, and some of that was just a little bit of playing around we did with some aileron end plates just to see what effect we can have on roll rate. Because it's a high wing, the ailerons don't tend to roll the aircraft quicker on aileron alone. And you talk to aerobatic pilots. In fact, we spoke to one just yesterday, another person, and you know, that's a normal thing. You know, again, you go to like a Citabria versus a low wing aerobatic airplane. You can roll the high wing airplane really quickly if you use rudder. But an aileron only roll just isn't quite as fast of a roll rate as a low wing airplane. And that's what we're experiencing in the high wing versus the Sonex. And that's just sort of the nature of the beast. So it may be that something like this tip fence that you can see we just have screwed on, actually with just riv nuts right now, is something that, you know, when you take off the full span tips and put on the end plates, you might also put these on just to enhance roll rate a little bit. We may also just make the ailerons a little bit longer. In other words, shorten the flaps by maybe 10 inches or a foot, and increase the span of the ailerons by the same amount. This airplane does have huge flaps, and just like the Sonex, you kind of really never need all that. So it is a lot of flaps. So we have room to do that. So more will be coming in that evaluation, and you'll be seeing, you know, hopefully, you know, towards the end of the month, a little bit more from us, where you'll actually see us doing some aerobatics with the airplane. So more to come. I've been telling people all week that I really wish that this webinar had been scheduled 2 or 3 weeks from now, because we have a lot coming in the next few weeks that we could actually show you the results of all these things that I'm talking about. We also, again, things taking longer than you'd like them to, we received the wing tanks finally. The molds were done, and the rotomold tooling was done, and we got our first sample tanks. I picked them up, last week, I believe it was, or the week before, and we just, you know, haven't wanted to take the airplane down to go ahead and do the installation, which of course we'll have to do here in the next couple of weeks. Excuse me, we'll probably wait for a, you know, weather opportunity, the next patch of bad weather, you know, rainy and crappy weather. We'll probably take the airplane down and do that installation. So it is a 5-gallon tank, like I talked about, in the wings on each side, in that non-removable center section of wing. And I've had people ask, well, why don't you put 10-gallon tanks in the wings? You know, well, yeah, why don't we put 60 gallons of fuel in the airplane? You know, it's all about weight and volume and gross weight and useful load. There has to be a limit somewhere. So 30 gallons is the reasonable limit that we've assigned for this airplane for maximum fuel load. And also, this is the biggest tank that will fit in that non-removable inboard section of the wing. That'll fit nicely. And so that's what we're going with. As I've talked about before, these tanks, you can just gravity feed this fuel into the main tank when you have room for it. And as I said before, you know, you wouldn't have any fuel in them for the aerobatic mission. Also, as you can see in the text here, a couple of things. One, this 5-gallon tank makes a great tank for people building ultralight. So you'll see the tanks available from us here soon on our website for people not just building a high wing, but hey, if you got an ultralight and you need a nice rotomolded 5-gallon tank, that can be somewhat conformal to being inside of a wing, as you can see that profile picture in the top middle. We got them. And so those will be available soon. So that's pretty cool. Also, thanks to our founder, John Monette, he is in his retirement back to restoring Piper Cubs. And he has wanted for years to do rotationally molded Cub tanks. And so he's finally made the investment. And when I picked up the Highwing tanks, I also picked up the first sample Cub tanks that you see in the picture there. We had one molded in black plastic and then two in the traditional blonde color. Of course, the black plastic is maybe a little more in keeping with the vintage look. Looks like the old tank, the old metal tank. The blonde color is nice because you can actually look at it and see the fuel. John actually masked a sort of a visual fuel window, if you will, with masking tape on the back of one of these blonde colored tanks and painted the back of the tank black, and that actually turned out really well as well. So you'll be seeing more from John and us on these Cub tanks if you're a Cub guy. And for experimental Cubs, you can use them. For certified Cubs, can't use them yet. John is investigating, kind of what do we have to do to make it legal to be able to use these new, much safer fuel cells in a certified Cub installation. So these are that typical 10 to 12 gallon configuration, same shape and form factor and everything as what's in your J3 Cub. Load testing, so that's another thing on the task list. We got a lot of work to do here, folks. And so we're getting ready here again in the next couple of weeks to do our horizontal tail load test. Because we are going for eventual ASTM compliance, we do have to do an asymmetric version of the test, which we haven't traditionally done in the past. So you see in the picture on the left there, instead of just having the horizontal tail itself on a big steel I-beam and load it up with weight, we had to build a sample section of fuselage underneath it to make sure that it can handle the torque loads of the asymmetrical test. And we're also testing the elevator on it as well. So we'll be doing what we call case A and case B testing, which basically is, if you know anything about this subject of engineering, case B is your forward tail spar, your load centered there, and case A is the aft spar, and we wanted to be able to include the elevator itself in the case A test. And you can see there on the right the diagram of the load cases. So when we do a static load test, whether it be a wing or a tail, we engineer specific load cases that we progressively load the structure, and each case simulates the actual lift distribution on the surface. In other words, you can't just throw a set amount of weight on the structure willy-nilly. You have to actually locate the weight properly, depending on what station on the span of the structure you're putting the weight on. And so this shows the asymmetrical case. A for asymmetrical, or symmetrical case is case 5S, and that's where we have that full load on the left there on both sides, which is really the symmetrical version of the ultimate loading case. So we'll test to ultimate and beyond until well, we probably won't find a failure point on the tail. The way we build tails, it's really hard to get enough weight on them to actually break them. But maybe we'll yield something or cripple a spar channel or something. After this, then we have to also do the load test of the wing, which is a much larger undertaking. And we are beginning to cut and prep parts to build out that sample wing section, and it will also involve a significant portion of the forward fuselage because of it being a high wing, and the way that we're connecting to the wings is different, and everything is different. So this will be a combined fuselage and wing test that we do, like we do for all of our structures. Tricycle gear. So we are, of course, offering a tricycle gear version of the airplane. And as I mentioned before, that will be the second prototype that we have in our factory. I just ran out of time to go into the SolidWorks model and actually get a nicer, more complete picture of the tri-gear that we have, version that we have designed. Essentially, you know, I hate to minimize engineering tasks, but this is basically kind of a no big deal. If you are on the, you know, on our wait list, on our deposits list, and you want tricycle gear, you are certainly more than welcome. You will not lose your relative position in line with other tri-gear builders if you want to wait until we finish and fly a tricycle gear high wing. But if you want to just get building as soon as possible, and you trust us, which you do, I think, if you're a deposit holder at all right now, yeah, you can definitely start building the kits when they're available, and we can get the landing gear kit for the tri-gear to you when we have it done and have it flown. And you know, we do not have a concern about this. We know how to do tri-gears. It'll be the same system as a Sonex, direct steering nose wheel. We actually might enhance the steering a little bit, and I'll talk about that at a later date in terms of what we're doing, but it should work out well. Plans, of course, again, a lot of work to do. We're starting to work on the plans for the aircraft, and this will be the first time, this is really the first airplane that we've designed start to finish from SolidWorks. Everything else has been some 2D CAD packages in combination with SolidWorks, or in the early days, no SolidWorks at all. So because this aircraft is modeled completely in SolidWorks by definitely the best SolidWorks driver that we've ever had at Sonex, so it's a very high quality model that's performing very well in the program. We will be using SolidWorks to generate the plans. So if you're familiar with the Sonex plans at all, or if you're not, I won't spend too much time going over the plans features. I'll just say that the Sonex plans are widely regarded as some of the best in the business, and I agree. Stand by that claim. We'll be doing everything we can to make these drawings just like the Sonex plans. If you've been on the bleeding edge of one of our new models in the past, you know that it takes a while, or any new kit, you know that it takes a while to get the plans. You might have parts before you have plans. And doing the SolidWorks generation of the plans should hopefully largely, if not completely, avoid that, where you won't be waiting for plans drawings as long as you maybe would have in the past. So a lot of just really streamlined workflows, all the same Sonex drawing features, and as well as some new ones. You can see, hopefully you can see this large enough on your screen. It's hard when you have so much white space, but you'll notice the border, you'll see some tick marks, and maybe you can make out some letters and numbers. But basically we have a alphanumeric coordinate system now in this new plan set, which is really great for tech support when you're talking to somebody on the phone or over email and they're having trouble finding something on the drawing. You can say, oh, look in quadrant A2, and there it is, or whatever. But otherwise, yeah, I mean, we're going to try to have more isometric views to give you a better visual representation of how things go together. We're probably going to be expanding sort of the number of pages by breaking down, maybe not showing as many assemblies on a single page. So we're just, you know, doing what we can to take a great plan set and make it even better for the next airplane. Production planning. So, you know, we've been talking for a while about when our kit's going to be available. And, you know, we set a fairly ambitious, I laugh, but we set a fairly ambitious target shipping kits, you know, by the end of the year. And yes, we have a lot of work to do, but I definitely feel confident that we'll be able to get things rolling, certainly by then. Tail kits will be definitely the first things available to ship. Hoping November, maybe. The tail kit, as you saw that last slide, the tail kit plans are sort of well underway in draft format right now. Of course, we got to sit down with everybody and review them and tweak them and make them right, make them perfect. And of course, we want to finish this full span testing, wingspan testing, to make sure that we don't want to make any changes as far as the rudder. But otherwise, we're ready to go. Probably the longest pole in the tent is the fiberglass tail tips themselves. We've been talking to the fiberglass vendor, and they feel like they can meet the volume on time. Hopefully it works out. I only have some hesitation there because we are tweaking the tail tips a little bit to fit a little nicer, fit a little better than the first set that we had made. So they are having to work the molds a little bit. So hopefully they can get that done quicker. They already fit pretty easily, but we just had to adjust the profile at the leading edge a little bit, and that'll make them even better. Fuselage and wing kits, we're really shooting hard for something in the January timeframe. And around that time, around December, January, we'll be taking those same parts and starting to put together quick build kits in our shop. And we're gearing up for that, looking for even expanding our staff and doing some other things to make that process as efficient as possible. We have right now, the official number as of today is 96 kit reservation deposit holders. There have been a few cancellations, medical and life changes and otherwise. So I'd say the minus cancellations, the real number is, I want to say it's probably about 86, maybe 87. And half of those people have indicated they want a quick build kit. So we've got our work cut out for us in the quick build department. And so we're going to be building the kits in big batches. We're going to be clearing some space, moving some airplanes into nearby T hangars outside of the Sonex hangars, and letting shop space overtake more of the facility. And like I said, it's hiring some staff, and just building these things in big batches as much as possible. So that's pretty much all I have. Pricing, by the way, you can see there, $39,000 for the complete airframe kit. If you haven't seen enough yet and you want to wait and see, but you want to stake your place in line, be number 97 or above, you can place that kit reservation deposit for $500. That is refundable, less a $50 cancellation fee if you need to. But that will stake your place in line. Otherwise, if you love what you see and you just are raring to go, you can put your money down on a kit, your 50% deposit. Either way, you will have a position in line. So don't worry if all you want to do is just do the kit reservation deposit for now. When we finish flight test on the tail dragger, we will go to every kit reservation deposit holder and say, hey, this is, here we are, this is the final numbers. It's time to either go forth with a full kit order, or we're going to give you your $500 or your $450 less cancellation fee back, and you'll lose your place in line. So that'll be coming, again, hopefully sometime in the November timeframe, depending on how the flight test process continues, and of course what the weather here in Wisconsin does to us. But that's where we will be at. And of course, if you just want to start with a tail kit, there you see the price at $22.50, $55,000 for a quick build kit if you want to get the fuselage and wings built for you. So I'll open it up to questions. Looks like we got about 20 minutes to go here, Tim. And what do you got?
Thanks, Mark. Yeah, we got first William's question. Will the kit be final hole sized or just match hold?
So to start, it will definitely just be matched hold. And really that has a lot, the reason why has a lot of answers. One is, yes, we have a CNC router. However, we really need a little bit better one to hold the tolerances that we want to be able to hold for full size matched hole. Also, because we only have one router and so many people, with the large volume of orders that it looks like we're going to have, we probably will not do it all in the router. So we'll probably have some laser cutting. Now, don't let that scare you if you have a Vans kit. I'll just we've been laser cutting since 1998 and have had no problems, and we use a completely different alloy. We use 6061 T6, so no worries there. We're not using 2024, but we don't want a full-size match hole with laser cutting. I don't personally believe in it from an engineering perspective, just my opinion. So for now, discretion is the better part of valor. You will have a lot of holes that cleco together right out of the box, but yes, you will have to updrill them and deburr them.
Michael wonders, what engine is planned for the tri-gear prototype?
Good question. So we work with all these avionics and engine manufacturers, and they help us because it's in their best interests to get their equipment in a new design that's going to be popular. And so, like UL Power furnished an engine, Rotax has furnished a 915, and that will go in the tri-gear. Now, that'll be plenty of power, 140 horse. With that big torque curve, so that'll be even though the tri-gear will probably be a little bit of a fatter airplane from a weight perspective with the extra wheel, and it'll probably have an autopilot on it as well and things like that, and then the BRS, and they'll have no issues with that that much power. Now Rotax only has a loaner program, which I've complained about. They're not just going to give us the engine like UL Power did. But what I'm really excited for, and what I really love to do when we're done testing the Rotax, is go look at an engine company in France called Turbotech. They basically build a 915 drop-in replacement that's a turboprop that burns less fuel, slightly less fuel than the 915 in cruise. And if you've seen Dave Hirschman's article on AOPA Pilot and the video that goes along with it, it is a truly revolutionary, very exciting engine package. Now, it's not cheap, but it would be a great fit for this airplane, and a lot of fun too. So I hope to be able to use that engine someday in something, maybe the tri-gear Highwing.
Kenneth wonders, will there be opening windows in the doors?
Not really planning it. This is a fast airplane. There's really no reason or desire to be able to open the window in flight. Cruise around 130 to 150 miles an hour indicated. You're not going to want those windows open. We do have very good vents. Maybe if someone wanted to do a special like photography mission or something, we can look at doing some sort of a blast deflector or something. It's a home built. If you want an opening window, make one. But we're not planning to do one.
Chris wonders, can the Highwing doors be easily jettisoned with the added tabs that hold the top of the doors closed?
Yeah, it's just like again, just like a Citabria. It'll be essentially the same deal. The Citabria also has two, I call them dogs or tabs, and so it's the same deal, same procedure.
Jerry wonders, what's the VNE speed going to be, and Yellow Arc starts at what speed?
VNE is 200 miles an hour. Yellow Arc, oh man, you're scratching my memory banks here, Jerry. It is very close to the Sonex. It's yeah, sorry. It's in the mid 100s, 150. Maneuvering speed's about the same, about 125 miles an hour for maneuvering speed too.
Bruce wonders, how will the fuel cap filler be done on the 5-gallon wing tank? Will it be flush?
No, so like the picture that you see here, it's our traditional, what they call a couch cap, and it will be recessed under the wing, so it will not protrude. There'll be a door and you'll just open that door up and you'll access the cap underneath. And that's actually good because we are going to, at least in our first testing, work with a vented cap, which just simplifies. It's one less fitting, bulkhead fitting we have to put in the tank to vent the tank. And hopefully we like that. I mean, a lot of other airplanes have done it in the past, especially older Cessnas and things. So that's the plan.
Mark wonders, how will the wing tanks connect into the fuel system? Do they feed to the main tank or separately feeding the engine?
So as I said before, they will gravity feed into the main tank. So you will leave the valves closed until you have room in the main tank, and until you have at least 10 gallons or less, or 5 gallons. Let's say if you only want to dump one side in, or I guess you say 15 gallons if you only want to dump one side in and not both. The main tank vent actually goes all the way up to the wing as well. So you could actually just leave the valves open all the time. Maybe. I'll tell you later whether that's a good idea or not after we try it.
Let's see here. Paul wonders, any reconsideration for the YX empennage?
No. So like I was talking about when I was talking about the rudder power, the wash of the wing on a high wing goes through the tail, and that makes a Y-tail too turbulent. It would be unpleasant.
Mark wonders, could Vortex generator kit be available in the future?
I'm not a big fan of Vortex generators. It's these wing plates on the ailerons that we've been playing around with make me itch enough. I just don't like I don't like aerodynamic band-aids. Can you do it? Yeah, sure. The enterprising home builder can do it. If we ever get to SLSAs, we'd want to have a lot of flight tests to see if they're worth it, which I doubt it.
William's looking for Sonex Highwing merchandise. Any chance that'll be available on the website in the near future?
Oh, definitely, William, and I wish I had it for you today. I mean, we just don't have enough hours in the day. As you can see, we're running through a very ambitious and busy development cycle right now. But yes, maybe even in time for the holidays, we're going to try to get a t-shirt and a hat going on our website and maybe some other stuff. But yes, we will definitely have merch for you.
Robin wonders if you have any data for takeoff and landing numbers.
As far as distance, very Sonex-like, and again, it'll depend on your engine. You're looking at a 600-foot roll or so on a hard surface. One of the things I didn't mention here is that, and this was kind of due to just a basic sort of modeling error in the SolidWorks model. We had intended the gear legs to be about 2 inches longer, and because the gear legs are swept back, that would actually make the gear about 1 inch taller in total. We found that just one of the reasons we put 505 tires on it wasn't because of all the people online belly aching about the fact that they thought our tires looked too small, but it was because we wanted to change the gear geometry a little bit to improve the takeoff performance, get it back to where it should have been as far as the angle of attack on the ground. So actually we are going to be installing the right length gear legs here very soon. And yes, you could still do the 505 tires. Of course, it's always a balance with, visibility over the nose. We want it to be, sort of, again, that Sonex, great Sonex reputation as far as having, for a tail dragger, having very good visibility over the nose. We want to retain that. Yeah, that's where that's at.
Edward is wondering, is there plans for a float plane option?
So I've had a few people talk to me about floats, very doable. I can't tell you when we will get to it. I've got one guy on the deposit holder list who's planning to just to do it. And You know, we've done it on the Sonex, kind of obscure Sonex trivia. If you aren't familiar, the Sonex actually has been on amphib floats. They were Czech Airworks amphibious floats, and with the Jabber 3300, and the airplane still cruised at 130 miles an hour, if you can believe that. And the airplane flew really well. Basically, we started with a tail dragger, and the front mount struts plugged into the landing gear mount receptacles that are in the motor mount, and then the aft struts for the floats go into a simple machine fitting that goes basically bolts onto the fuselage brake between the tail cone and the forward fuselage, where we already have heavy fittings with bolts. So yeah, we kind of already have the game plan. Again, I don't know when we'll ever get to it, because yeah, you know, not enough hours in the day. But yeah, I hope to. And I have a feeling that an amateur builder will probably beat us to it, and you know, I'm pretty sure it'll fly quite nice.
Allison wonders, will the wings be easily removable for trailer transport?
They will be removable. And fairly easy. Not as easy as a Sonex. I didn't go over this because of, again, not trying to use up all of our webinar time on stuff we've covered in past presentations. So I invite you to look at the archives there for that answer. But there are wing ties that hold the wings on. They involve several bolts. So you'll be opening up access panels on the bottom of the wing to remove those bolts. There's also a cuff strip that goes around the wing joint, which carries some of the pitching moment loads, some of the skin loads. So you'll be removing that. That's on with nut plates, and you'll also remove the flap, which is basically a matter of a piano hinge pin, so not a huge deal. But yes, they are removable, and I would say, yeah, in about an hour you can get it taken apart and put it on a trailer. So not the 20 minutes of the Sonex, but more like the hour or so it takes for a subsonics, because it's basically the same system as the subsonics.
Carl wonders, is there going to be an optional machined angle component kit, or will this be included?
It will be included, so you don't even have to worry about an option. The nature, and don't be offended, but the skill level of today's home builder is not what it was 20 years ago. And so we balance, when we do upgrades like optional machined angle components or optional pre-built spars, that's a way for you to save money. But in truth, 99% of the kit builders build it, and in modern times, builders just don't have the patience for not having it. And they're newer builders. In other words, they're learning the skills. They're still in the learning process as builders.
Mark wonders, will any prototype have the BRS?
Yes, so the plan is that the Tricycle gear prototype will have the BRS. And as I mentioned, we had a great meeting again at AirVenture this year with BRS, and in terms of getting the ball rolling, in terms of them doing all their side of the engineering work for it. It will go in the baggage compartment. It'll exit through the window that's in the ceiling of the baggage compartment, and all of the harnesses will just be flat, conformal to the top of the wing. So it'll be nice and easily fared in, and to the main spar, and to the fuselage in the back. It'll take, probably, what did they say, 18 pounds, let's say 20 pounds with mounts and everything out of your baggage capacity. But if you really want it, you can have it.
Larry was wondering, will the auxiliary wing fuel tanks have gauges?
That's up to you. We actually are playing around with a new to us fuel probe. We traditionally have used the capacitive type probes, the ones currently made by Red Avionics in all of the Sonexes in the past. That's what we show in the plans for existing Sonexes. We, in this airplane, have the B-Light fuel probe, which is actually a very sensitive pressure gauge, and it meters fuel based on the weight of the fuel, based on column pressure. So one of the interesting experiments that we're going to do when we put the wing tanks in is to open the valves and see if it can sense the extra column pressure, which will be interesting. But if not, and if you want a fuel level indication in there, you can easily do it. It's just a matter of adding another bulkhead fitting and wiring it up to your avionics, but very doable.
Kenneth
Or you can go
wonders,
without it. You can just make sure in your pre-flight that they're full, and then as you add the fuel in during your flight, make sure that you watch your main tank fuel level go up to where you think it should.
how is the toe brake installation working out?
Oh, very good. We're very happy with it. We are using our aero conversions, aero brakes, we call them, our hydraulic brake units, and we're combining them with Matco master cylinders. They're working really well. We haven't done the co-pilot side slaved, I'll call them, the cable linked brakes yet, and we just because we haven't had time. But we will be testing that as well. If we like it, that's great. That's a lighter and cheaper way to have the brakes on both sides. If we don't like it, well, then you'll have to buy another pair of master cylinders, and if you want brakes on the co-pilot side.
Getting close to the end here. Let's try and get a couple more in real quick. Warren wonders, will there be an interior upholstery kit available?
Oh yes, definitely. Yeah, of course. So if you saw the seats at AirVenture or any of our past webinars, that's the first set of seat cushions that we got from Flightline Interiors, who does all of our interiors as well as Vans Aircraft and some others, located right here in Wisconsin, which is convenient. And actually, we just had them here not too long ago to make some tweaks to make them a little bit better, especially as far as the seat back folding and where the seat belts attach and things like that. So hopefully we'll be getting version 2 of them soon. We'll also be looking at some options for booster cushions, definitely with the amount of headroom in the airplane. There'll be a lot of people wanting booster cushions for it. And then also another thing that we're going to do is, the nice lightweight, door cards. So the doors look a little nicer on the inside, maybe with some pockets or optional pockets or whatever. And some sort of closeout for the back of the baggage compartment, of course, as well. And one thing I didn't mention, I know we're really tight on time here, Tim, but when I was talking about AirVenture, I want to point out this picture again. So on the left there, that's Tom Wilson. He is a giant man. He is a very tall individual who is mostly legs. He's got a relatively average length torso. He's got very long legs and very wide, broad shouldered, and Paul is a more average sized individual. I'll say it. I'll say, and they fit in the aircraft together really nice. And although his knees come up a bit, he does have his feet on the rudder pedals, and he can fit and could fly the airplane. So really can fit a much wider range of pilots in the airplane.
Well, great presentation, Mark. Sure to appreciate the update here. It's just awesome to hear these details of a brand new aircraft in development and the flight testing and the tweaking you're doing based on flight testing. So, best wishes for continued success in your flight testing and bringing this to market so we can all enjoy this really cool new aircraft, which isn't that common nowadays. It's actually pretty rare. So congratulations. Looks like we had about 300 people tuned in tonight to our webinar. Take a moment and share closing thoughts with us.
Well, thank you, Tim, and thanks for your kind words. And thank all of you for attending tonight. And a huge thanks to our I'll say it's current list, like I said, is maybe 87 folks who have put money down on this airplane as a placeholder deposit, and having the confidence in us based on everything we've done in the past and what they've seen that we're doing on this airplane so far. Hopefully I've shown all of you enough tonight to satisfy you that we are being good stewards of your deposits, and we are making progress. Maybe not always as quickly as we want to, because that's just the way life works, especially with complex projects. But we're getting there, and we're just really happy with the airplane. So thank you again, everyone. And if you have questions, please reach out. You can see the email there, sales@sonexaircraft.com. That comes directly to me. Give me a call at the phone number you see there. Join our mailing list, and let us know if you want in on getting in line for Highwing.
Great presentation. Thank you, Mark. And to everybody who tuned in, thanks for joining us, everybody. Have a wonderful evening. See you next time.